Hello guys, welcome to Leetcoding. In this video, we are going to see the Leetcode problem number 2279, maximum bags with full capacity of rocks. Let's get into the problem. So, the problem statement is you have n bags number from 0 to n minus 1. You also given zero index integer arrays, capacity and rocks. The ith bag can hold a maximum of capacity of I rocks and currently contains rocks of I rocks. So this capacity array and rocks array plays their role here, and you are also given an integer additional rocks, the number of additional rocks you can place in any of the bags. So you need to return the maximum number of bags that could have full capacity after placing the additional rocks in some bags. So this is all about our problem statement. Let's get into the problem definition. So the first step to solve any problem is to define the problem clearly. So the input for this problem is uh, capacity array. Just n. So there are n bags numbered from 0 to n minus 1. So this is not an input, but the thing which we need to know. So the capacity of I is nothing but array which indicates the maximum capacity of rocks each bag can contain. So yes, and there's also input. The input also contains a rocks array of size n, which will contain the number of rocks contained by each bag currently, and we are also given an input called additional additional stones. Yeah, so additional stones is nothing but number of stones which we can place in any bags. So output is output which we are required to find is nothing but maximum number of filled bags after placing the additional stones. Yeah, so how to solve this problem? So we'll see this solving in approach part. So this is all about our input and output. So there will be two integer arrays and integer, and we are also required to find out the maximum number of filled bags after placing the additional bags. So this is what we are required to find. So let's get on to the approach of this problem. So the second step is approach. So there are n bags. So let's take a square in a rectangle to indicate each bags. So the bags are labeled from 0 to n minus 1. So let's say we have 6 bags here. So the bags are indexed from 0 to 5. So each bag can have a capacity, that is the capacity is nothing but the number of stones. Capacity is nothing but ma maximum number of stones, that is rocks a bag can contain. So this is the capacity, and this is all about the first is the naming is nothing but 0 to n minus 1, and capacity of each bag means the maximum number of rocks a bag can contain, and rocks array will be indicate. So rock will be nothing but number of stones currently present in the bag. So additional stones is the stones which you have now. So additional stones need to be placed into the bags. So there is no strict rule that we need to place all the additional stones, that is additional rocks. So I have used rocks and stones alternatively, so please look it carefully into it. So additional rocks is nothing but we need to place additional rocks into the bags. There is no strict rule to place every rocks into the bag. So we need to find the maximum bags that can be have filled capacity after placing additional rocks. So how can we find this? So let's say we have a bag of size 5. So capacity of the bag is 5 and rocks currently present is 2. So the rocks required to make the bag full is nothing but 3. So we need to we need 3 stones, that is 3 rocks, to make this bag fill. So this is the main point we need to know is the required. So we need to find the required stones for each bag. So why do we need it? So after finding the required stones, so required stones of each bag, we can easily find the maximum bags that can be filled. So after finding this, we are going to sort this array based on the ascending order, because what we are going to do is we are going to fill the bags based on minimum requirement order. So requirement is nothing but number of rocks that is required to make the bag full. So we are going to select the minimum requirement bags, and we are going to fill those bags. And after if we, let's say we are required to have 2 stones, let's say we have 3 rocks already. So yeah, 2 rocks already, and we need 3 rocks. So let's say we have additional stones as 4. So when we fill this bag, which is let's say there is a zeroth bag, when we fill this, our additional stones, 3 of the additional stones will go here and only 1 will be remaining here. So this will be reduced, and finally we need to find the count. So this is the logic which we are going to use. That is, we need to find, the first step is to find requirement, and the second step is to find to sort the requirements and fill the bags based on the minimum requirement order. So this is what we are going to do, and we are going to see how many bags we are going to uh, fill in the maximum. So how much bags we are going to fill finally when we choose this approach. So this is the optimal way to fill the bags. So let's look on to the examples so that you may get a clear idea of this approach. Yeah, now we'll move on to an example. So let's take the sample example which is given to us. So So this is the sample example. So in this there are 4 bags number from 0, 1, 2 and 3. Let's number them. So we have 2 rocks. So firstly we are going to find the requirement matrix. So requirement array. So in this we are going to store the required stones that are required, that is rocks that are required to make the bags full. So first bag requires capacity minus rocks. So a requirement is nothing but capacity minus rocks. So this is the requirement formula. So for each bag we are going to calculate the requirement. So 2 minus 1 will be 1 and 3 minus 2 will be 1 and 4 minus 4 is 0, 5 minus 4 is 1. So this is the requirement for each bag. So now what we are going to do is we are going to find the filled bags. So we are going to keep filled bags count as 0 initially. Now we are going to sort this array. So after sorting this array, it's going to be 0, 1, 1 and 1. Now we are going to use the additional rocks to fill the bags in order. So firstly we have requirement as 0. So we'll store 1 here. I mean the additional rocks is greater than the requirement. So we'll reduce it. So we don't need any additional rocks for this bag to get filled. So we'll just remove it and add it to the fill bags. And now we're going to next index, and the next value is 1. So the additional rocks one rock from the additional rock is made to enter into this bag so that the bag will be filled. So when we use this additional rock, one rock will be gone from additional rocks and this bag will be full. So we'll increment the filled bags count, and now we are going to take the other, next minimum requirement bag, and it is 1. So additional rocks, one rock will go into the bag so that the additional rocks will be 0 and the bag will be full. So the filled bags will get incremented to 3. Now we are going to take the next bag, and now we don't have enough additional rocks to fill this bag. So we stop the iteration, and now we are going to return this filled bags. So this is the logic. So we'll check whether the answer is correct or not, and the answer is right. So 3 is the answer. So this is the logic. So the time complexity of this approach is nothing but big O of n log n. Since the sorting requires big O of n log n, so time complexity will big O of n log n, and I'll say how to remove this requirement array. So we don't need a requirement array. So we'll be using a priority queue here. So I'll discuss this in the coding section. Now we need to find the space complexity. So the space complexity will be big O of n, since the requirement array we are using here uh, goes up to the maximum of n size, and approach we have used here is priority queue, and sorting. So that's it, guys. I think you will get a somewhat idea about this approach, and I'm sure that you will be clear in the coding section. Let's move on to coding section. So uh, firstly we are going to create a priority queue of integer. We'll call this as required rocks new priority queue. So by default priority queue will have order of ascending order. So that you will have ascending order based on integer. So now integer will have priority will store the integers in ascending order. Now we are going to iterate over each rocks, each bags. So int I equal to 0, I less than. The bag size is nothing but capacity dot length. So we have n bags, so we are going to iterate over 0 to n minus 1, and required stone for current bag is nothing but capacity of I minus rocks of I. So if yeah, I'll discuss that step in other upcoming approach. So we're going to add the required rocks for the current bag into the priority queue, which is required rocks. So add it. So after this, we're going to have a variable called filled capacity, which will be initially 0, and while required rocks part is empty. So until the priority queue is not empty, we are going to use the while loop, and additional blocks, additional rocks is greater than or equal to required rocks dot peak. So this required rocks dot peak will return us the maximum, that is the minimum number of rocks required by a bag in the required rocks priority queue. So when this condition is true, we are guaranteed that we have a guarantee that additional rocks can fill the bag which we have at the top. So we'll reduce the additional box. So after reducing it, additional rocks will be uh, the stones that which you have used. So require rocks dot remove. So when we remove the value from priority queue, we get the minimum value. So we will also increase the filled capacity plus plus. So after this, we will return the filled capacity. So we'll name this as filled capacity count. Let's check this out. It's working fine. So there is a better optimization than this. Like there's a possibility that a bag is already full. So when the bag is already full, we don't need to add it to the required rocks. So we'll directly use this, directly increase the value. So we'll have this value here, and if required is 0, we'll increment the filled capacity count and continue. So we don't need to add the required that is the required rocks into the priority queue. So we'll continue. So let's take this up. This will help us to save time a little bit. So yeah, let's submit it up. Accepted. And that's all about this video, guys. Thanks for watching this video and have a great time. Happy coding.